So for this next problem, we're given the line of best fit. It says y equals 0.4x, 0.48x plus 1.32 is the line of best fit, the least squares regression line for the data and scatter plot shown below. And then it says predict the value of y when x is the number 15. We're going to do that part. That's really a pretty easy part. But before we do that, I want to review how do we get the least square regression line from a data set. So on our classroom calculators, there is a button that says data. And if you come along and you press that data button, right, all of a sudden now I have this place where I can enter values. And I'm going to enter all my values for x in list number 1. So my values for x are 3 and then 7. And then there's an additional 7 and then a 5 and an 8 and a 10. So I've entered all values for that, my x values in the first list. In the next list 2, I'm going to enter all the values of y that correspond to the correct x values. So when x was 3, y was 2.5. When x was 7, y was 4.5. When the second x, the 7 was, x was 5. When x was 5, y was 4. When x was 8, y was 5. And then the last one, when x is 10, y is the number 6. So when you look at this, this table, right? If I look at this table is clearly not a function, right? Why is it not a function? Because this value of x has, when x is 7, there's 2 different outputs. And for a relationship to be a function, each value of the domain can have only one value. But this is kind of a different concept, because what I've done here is we're collecting data and we're using that data to make a model. This line, right, this line is attempting to model the data, and this is the equation of the line that's modeling that data. Now that we have our data entered in our calculator, we have a technique for finding the equation of the line that models that data. How do we find that? Well, now that our data is entered, I'm going to go ahead and press second. And instead of, the reason why I'm pressing second is I don't want data, I want the stats functionality. So I'm pressing second and then the same button as data to get stats. This is 2 variable stats because we had both an x and a y. I'm going to press enter and I'm going to go down to where it says calculate. And there's a lot of information about this small data set. The things that we're looking for are way down here on lines D, E, and F. If you'll notice on line D, it says A is 0.477. Well, it turns out that this calculator is using the variable A for slope instead of M. So that 4.77 becomes 4.8 when I round it to the nearest tenth. So you can see on line D where it says A is equal, that's giving me the slope of this line. So I can see my slope right there on line D where it says A equals. And then right below that, it says B equals, which is nice because that's the variable we use for y-intercept, 1.318. If I round that to the nearest tenth, I get 1.32. So what I'm looking at right here is I'm looking at both the slope and the y-intercept from my calculator. The other thing that it has on this last line, where it says line F, is this is our correlation coefficient. And this talks about the strength of this association. The association strength is very strong, right? It's 0.977. The largest this number could be would be 1, and that would be what happens when all these data points are exactly on that line and there's a positive slope. The smallest it could be would be -1, R could be -1, and that's the value we would get when all these data points are on a line and the line has a decrease or it's a negative slope. So the equation of this line of best fit for this table, right, we can see from our calculator is y is equal to 0.48x plus 1.32. Now, that's the equation of this line. And again, this line is attempting to model the data. It's attempting to tell me what's happening. I didn't follow the line very well. And this question says, predict the value of y when x is 15. So when x is the number 15, right, what's the value of y that's predicted? Well, we can see it happens right there. And we can get kind of a decent estimate just by looking at the graph. But also, we can get a much more accurate value of the prediction by just plugging in the number 15 for x. So I'll go ahead and hit clear on this calculator and leave all this stuff. And I'm just going to take the 0.48 and I'm going to multiply that by the input I'm interested in, which is 15. And then I'm going to add 1.32. So when x is the number 15, this model says that y should be around a value of 8.52. So this is the predicted y. This is the y that we would expect to see when x is 15.